Your alarm goes off, you silence it, sit up, and within the next 10 to 20 minutes, you do one of the following. You check your phone immediately, you drink a cup of coffee, you scroll social media, you hit the snooze button and check your phone again, or you eat a large meal within the first 30 minutes of waking. Maybe all of the above. These behaviors feel innocuous. They feel like simply being human in the modern world. And they are so normalized, practiced by the overwhelming majority of the population, that almost no one stops to consider what they are actually doing to the biological systems that govern their energy, their cortisol rhythm, their dopamine architecture, their blood sugar regulation, and their long-term health. I am going to walk you through the precise physiological mechanisms of 5 morning behaviors that are measurably harming you, and I am going to give you the evidence-based alternatives for each one. This is not a lifestyle lecture. This is a biological briefing. I've been a clinician for 15 years. The patterns I am about to describe are not theoretical. I see their downstream consequences daily in the fatigue panels, the cortisol profiles, the insulin resistance markers, the sleep quality assessments. The morning window, roughly the first 90 minutes after waking, is one of the most biologically sensitive periods of your entire day. It sets the hormonal tone for the following 16 hours, and most people are spending it in ways that guarantee an uphill metabolic battle before they have even left the house. If you want to understand your biology at the level where the interventions actually work, not the surface level tips, but the real mechanisms, subscribe and hit the bell. I am working toward a community of 50,000 people who want clinical precision in their health choices. Let us get into it. Let me give you the clinical picture first, because everything I am about to say will be more useful with the context of a real patient. She was 37 years old. She came to me for fatigue that was present every day, regardless of how much she slept. She was waking at 7, immediately checking her phone for 30 to 40 minutes in bed, drinking 2 cups of coffee before eating anything, and eating a large bowl of granola with fruit at around 9. She was exhausted by 2 in the afternoon every day, wired but unable to sleep by 11 at night, and had been gaining weight around her midsection for 2 years despite not significantly changing her diet. Her morning cortisol test, taken at 8 a.m., the correct timing for the cortisol awakening response, showed a blunted peak significantly below the normal range. Her fasting insulin was 14 microunits per milliliter, above the 10 that I consider a meaningful risk threshold. Her dopamine precursor markers were low. She was not sick in any conventional sense. She was dysregulated, and the dysregulation was being driven and maintained by what she was doing in the first 90 minutes of every day. Here is the master biology you need to understand. Your body runs on a circadian rhythm, a roughly 24-hour biological clock that is orchestrated by the suprachiasmatic nucleus in the hypothalamus, synchronized primarily by light, and expressed through coordinated waves of hormones, neurotransmitters, and metabolic signals. The morning window is characterized by a specific biological event called the cortisol awakening response, a rapid, sharp rise in cortisol in the first 30 to 45 minutes after waking that reaches a peak approximately 30 to 45% higher than your baseline cortisol level. This cortisol spike is not stress. It is the body's primary energizing signal. It mobilizes glucose, primes the immune system for the day, activates the prefrontal cortex for executive function, and coordinates the metabolic transition from fasting to activity. Think of it as the ignition cycle of a complex engine. The cortisol awakening response is supposed to fire cleanly and strongly, and then decline smoothly through the day toward low levels by evening, allowing melatonin and sleep pressure to take over. Every one of the behaviors I am about to describe disrupts this cycle in a specific, measurable way. Mistake 1: checking your phone immediately upon waking. The cortisol awakening response requires a specific input to fire optimally: natural or bright light exposure to the eyes within the first 5 to 10 minutes of waking, and a brief period of cognitive settling before the prefrontal cortex is flooded with external demands. What a phone provides is the opposite: Blue light dominant screen exposure within the first minutes of waking artificially activates retinal photoreceptors at a time when the gradual light ramp of dawn would normally be calibrating the circadian clock. But more significantly, the social and informational content of a phone, emails, news, social media, notifications, activates the amygdala and the dopamine reward system before the prefrontal cortex has had the chance to properly online. Research from the University of California, San Francisco, has documented that early morning stress activation, the kind produced by reading distressing news or work emails within the first minutes of waking, produces a sustained elevation of cortisol that persists significantly longer than the normal cortisol awakening response peak. This means the cortisol does not decline on schedule. By afternoon, you are running on a flattened, dysregulated cortisol curve rather than the clean arc your biology requires. The practical alternative takes 12 minutes. Neuroscientist Dr. Andrew Huberman at Stanford has published research demonstrating that 10 to 20 minutes of outdoor light exposure, or equivalently bright indoor light above 10,000 lux, within the first 15 to 30 minutes of waking, powerfully anchors the circadian clock, amplifies the cortisol awakening response in a healthy, appropriately timed way, and improves mood, alertness, and sleep quality that night. Keep your phone face down or in another room until you have had your morning light exposure and at minimum a 10-minute buffer of cognitive settling. This is not a luxury. It is a biological requirement for a well-functioning cortisol rhythm. Mistake 2. Drinking coffee immediately upon waking. Caffeine's mechanism of action is to block adenosine receptors. Adenosine is a nucleoside that accumulates during waking hours and produces progressively increasing sleepiness. It is essentially the brain's sleep pressure chemical. Caffeine does not reduce adenosine. It blocks its receptor, creating the sensation that adenosine is not accumulating, but the adenosine keeps building behind the blocked receptors. When caffeine wears off, the accumulated adenosine floods the receptors all at once, producing the characteristic afternoon crash. Now here's the critical piece that most people do not know. In the first 90 minutes after waking, adenosine levels are naturally low. They were cleared during sleep. The cortisol awakening response is at its peak. You are biologically at your most alert and energized. Drinking coffee at this moment provides relatively little benefit. You are adding a stimulant on top of a system that is already stimulated, but it does train your body to expect that alertness requires caffeine, gradually reducing the amplitude of the natural cortisol awakening response over time. Research from Dr. Andrew Huberman's lab and from chronobiology researchers, including Dr. Till Roneberg at Ludwig Maximilian University, has consistently shown that delaying caffeine intake until 90 to 120 minutes after waking, after the cortisol peak has naturally occurred and adenosine has had a chance to begin reaccumulating, produces superior and more sustained energy, better cognitive performance in the afternoon, and a reduced dependence on repeated caffeine doses to maintain function. The practical implication: wait 90 minutes after waking before your first coffee. Drink water during that window instead. This single change in timing, not the elimination of coffee, just the delay, measurably alters the cortisol and adenosine dynamics for the better. Mistake 3. Eating a large, high-carbohydrate breakfast immediately upon waking. During the fasting state overnight, your liver has been producing glucose through a process called gluconeogenesis, and your cells have been running partially on fat oxidation. In the morning, insulin sensitivity is at its relative daily peak, meaning your cells are most responsive to insulin's glucose-clearing signals. A large carbohydrate load at this time, a bowl of cereal, granola, toast with jam, a fruit smoothie, produces a rapid glucose spike that triggers a large insulin response. For most people, this is followed by a glucose drop that is steeper than the rise, producing reactive hypoglycemia, low-ish blood sugar, in the 1 to 2 hours after eating, which signals to the brain as an energy crisis and triggers cortisol release, cravings, difficulty concentrating, and irritability. This is not a character flaw. It is an endocrine cascade from a food choice. Research published in the American Journal of Clinical Nutrition has shown that high-protein, lower-carbohydrate breakfasts produce significantly more stable glucose and insulin profiles throughout the morning than isocaloric, high-carbohydrate breakfasts, with downstream benefits for satiety, cognitive performance, and afternoon energy levels. The specific protein target in the research is approximately 30 grams of protein at the first meal of the day, which activates cholecystokinin and GLP-1, satiety hormones that sustain fullness for 3 to 4 hours. Eggs, Greek yogurt, cottage cheese, or a protein-rich smoothie without high-sugar fruit bases are practical options. If you practice time-restricted eating and prefer to delay your first meal by 90 minutes to 2 hours after waking, which has its own metabolic evidence base, that is also a valid choice that allows the cortisol awakening response to run its course before you introduce the insulin response of eating. I want to pause here and ask you to drop your age in the comments. This is not incidental. The biology shifts at specific points, and it changes which of these mistakes is doing the most damage. Under 35, the dopamine architecture issue I am about to describe, morning phone use, and the reward system dysregulation it produces, tends to be the most impactful. Between 35 and 50, the cortisol rhythm disruption and insulin dysregulation become progressively more consequential as cortisol reserve naturally declines and insulin sensitivity begins to drift. Over 50, sleep architecture changes mean that the cortisol awakening response is already naturally blunted, making the morning behaviors that further suppress it disproportionately harmful. Your age tells me which intervention to prioritize. Mistake 4. Snoozing the alarm and returning to fragmented sleep. The snooze button feels merciful. It is not. When your alarm first fires, your body has, if you have had a sufficient night of sleep, already been preparing for waking for approximately 30 to 40 minutes through a process called sleep inertia clearance. Cortisol has begun rising. Core body temperature has begun increasing. Norepinephrine is activating arousal circuits. When you suppress the alarm and fall back asleep, you disrupt this orchestrated awakening sequence and in many cases enter a lighter stage of sleep or, briefly, the beginning of a new sleep cycle. When the alarm fires again 7 to 10 minutes later, you are now being pulled out of an interrupted cycle, and the physiological cost is higher than if you had gotten up with the first alarm. Research published in the Journal of Sleep Research has documented that habitual snoozing is associated with higher sleep inertia, the groggy, disoriented feeling after waking, for longer durations, and with blunted cortisol awakening response amplitude. The irony is that the snooze button, designed to ease the difficulty of waking, systematically makes mornings harder over time by disrupting the very hormonal sequence that produces the feeling of being awake and alert. The alternative is structural rather than motivational. Placing your alarm across the room forces you to stand and take several steps before silencing it. Research on behavior design from B.J. Fogg's lab at Stanford's Behavior Design Lab has shown that increasing the friction of a behavior is a more reliable way to reduce it than relying on willpower. Establishing a fixed wake time that is consistent within 30 minutes 7 days a week, including weekends, anchors your circadian rhythm more reliably than any other single sleep hygiene intervention, according to research published in Sleep Medicine Reviews. Mistake 5. Skipping morning physical movement. You do not have to do a full workout in the morning. The evidence does not require that. What it does consistently show is that some form of physical movement in the morning, even 10 minutes of brisk walking, produces benefits that differ mechanistically from movement performed at other times of day. Morning light plus movement simultaneously activates the circadian clock via the retinal light pathway and the sympathetic nervous system via proprioceptive and cardiovascular input, producing a compounding effect on cortisol rhythm calibration. Research from the Salk Institute's Gene Expression Laboratory has shown that exercise in the morning synchronizes peripheral circadian clocks, the biological timekeepers in tissues throughout the body, with the central clock in the hypothalamus, improving overall metabolic coherence. Additionally, morning exercise is associated with greater exercise adherence than evening exercise in multiple longitudinal studies because the window is not subject to the day's competing demands. For the dopamine system specifically, and this is where the phone in the morning issue and the movement issue intersect, morning exercise increases the baseline firing rate of dopamine-producing neurons in the ventral tegmental area. Research from Dr. Wendy Suzuki's lab at New York University has documented that even a single 20-minute aerobic exercise session produces an immediate elevation in dopamine, serotonin, and norepinephrine that improves working memory, attention, and mood for the following 2 to 4 hours. If you are starting your day by immediately hitting the dopamine reward circuitry with social media and phone notifications, a super stimulus that the dopamine system was not designed for, and then sitting down to work requiring focus, you are fighting an uphill neurochemical battle all morning. Exercise produces a clean, sustainable dopaminergic rise. Phone notifications produce sharp, brief spikes followed by rapid, habituating reward, the neurological equivalent of junk food compared to a real meal. Here is the complete morning protocol, assembled from the strongest available evidence. Wake with the first alarm. Before touching your phone, get direct light into your eyes for 10 to 15 minutes. Outdoors is best. A bright light therapy lamp is a valid indoor alternative. Drink 16 to 20 ounces of water. You have been mildly dehydrated for 7 to 9 hours. Move your body for 10 to 20 minutes. A walk, light calisthenics, or a full workout if time allows. Wait 90 minutes before your first coffee. Eat a meal with at minimum 30 grams of protein, moderate fat, and controlled carbohydrate content at whatever time fits your schedule, and whether that is immediately after waking or after the 90-minute fasting extension. Check your phone after all of this, not before. This sequence does not require dramatically more time than your current morning. It requires a reordering. The light, water, and movement take 20 to 30 minutes combined. The coffee delay requires no additional time. It is a postponement, not a removal. The protein breakfast takes no longer to prepare than a bowl of granola. What it produces in aggregate is a cortisol awakening response that fires cleanly, an adenosine caffeine dynamic that works with your biology instead of against it, a blood glucose profile that sustains energy and cognition, a dopamine system that begins the day with a clean signal rather than a spike and crash, and a circadian clock that is properly anchored for the following 24 hours. The research behind each of these components is robust and converging. Circadian biology, cortisol physiology, insulin biochemistry, and dopamine neuroscience all point in the same direction. The morning window is uniquely powerful, and how you use it has disproportionate effects on the biology of your entire day. Most people are not making deliberate choices in this window. They are defaulting to cultural habits, the phone, the immediate coffee, the sugary breakfast, that have no biological rationale and significant biological cost. You have more control over your morning physiology than you may realize. The biology is yours to work with or against. Your health is your responsibility, not the pharmacy's. I'll see you in the next video. I want to go deeper on the cortisol awakening response because it is so central to everything I've described, and yet so few people have ever heard of it, despite it being one of the most studied phenomena in human chronobiology. The cortisol awakening response, abbreviated CAR in the research literature, has been investigated in thousands of studies since the 1990s. And what the research reveals is that it is both a reflection of your current health status and a modifiable target for intervention. In healthy individuals, cortisol rises from its nadir, its overnight low point, by approximately 50 to 160% within the first 30 to 45 minutes of waking. Then begins a gradual decline through the day. The height of the CR peak is influenced by multiple factors: genetic variation in the hypothalamic pituitary adrenal axis, the quality of the preceding night's sleep, chronic psychological stress, immune activation, and the behavioral inputs of the morning itself. Research from the Trier Psychobiology Group in Germany, which has produced much of the foundational CAR literature, has shown that anticipated demands, waking up knowing you have a stressful day ahead, significantly increase CAR amplitude. Chronic fatigue syndrome and burnout, by contrast, are associated with blunted, diminished CARs that fail to produce the normal energizing peak. The CAR is therefore both a stress readout and a resilience indicator. The reason the morning phone check is so damaging to the CAR specifically is that it bypasses the natural cognitive orientation sequence, the brief period between waking and full alertness where the prefrontal cortex comes online progressively and immediately activates the amygdala with social threat signals, real or perceived. Notifications about missed messages, news headlines, and social media comparisons activate the same threat detection circuitry as physical danger. Research from Carnegie Mellon University has documented that heavy morning social media use is associated with elevated perceived stress and blunted HPA axis responsiveness, meaning the body's stress response system becomes less calibrated and less efficient over time. This is Tier 2 in terms of direct CAR measurement, but the mechanistic pathway is consistent with Tier 1 HPA axis physiology. There is also the specific issue of blue light exposure in the morning versus what the circadian system is designed to receive. Natural morning light is spectrally complex. It contains a full spectrum of wavelengths with a particular richness in short wavelength blue light that specifically activates the intrinsically photosensitive retinal ganglion cells that project to the suprachiasmatic nucleus. These cells, containing the photopigment melanopsin, are most responsive to wavelengths around 480 nanometers, which is precisely the peak emission of most smartphone screens. However, the irradiance, the intensity of the light signal, matters as much as the spectrum. Outdoor morning light, even on an overcast day, delivers 10,000 to 100,000 lux of irradiance. A typical smartphone screen held at arm's length delivers approximately 40 to 100 lux, dramatically less. This means that while the phone does provide a circadian signal, it is a weak and poorly timed one compared to genuine outdoor light exposure. The eye needs the high irradiance, full spectrum signal of outdoor morning light to properly calibrate the circadian system, and no current screen technology delivers this. Research from Dr. Sachin Panda's lab at the Salk Institute, published in Cell Metabolism, has shown in both animal models and human observational studies that consistent exposure to bright light in the morning is one of the two most powerful circadian synchronizers available, alongside consistent sleep timing. The practical implication is that even on days when exercise is not possible and the morning is rushed, 5 to 10 minutes of outdoor light exposure, sitting by a window if outdoor access is not available, though this is substantially less effective due to glass filtering, is a non-negotiable investment in the circadian architecture of your entire day. I also want to address the hydration question more specifically because it is frequently minimized and the biology is genuinely interesting. During a 7 to 9 hour sleep period, you lose between 400 and 700 milliliters of water through respiratory evaporation and transdermal loss without any intake. This means you wake in a state of mild hyponatremic dehydration, slightly concentrated blood, every single morning. This dehydration state has direct effects on cortisol. Research from the Journal of Nutrition has shown that even mild dehydration, equivalent to 1 to 2% of body weight, impairs mood, reduces working memory capacity, and increases the perception of task difficulty and fatigue, all of which are also produced by a suboptimal cortisol awakening response. The two effects compound. A glass of water, ideally 16 to 20 ounces, before coffee, before food, and before phone contact is the simplest, cheapest, and most immediately actionable morning intervention with the fastest onset of benefit. The broader framing I want to leave you with is this. The morning is not a neutral period that you are simply getting through before your real day begins. It is the biological setup for everything that follows. The cortisol rhythm, the dopamine baseline, the insulin sensitivity, the circadian synchronization. All of these are substantially determined by your behavior in the first 90 minutes after waking. This is not uniquely stressful information. It is actually empowering because it means that 90 minutes of intentional behavior each morning creates a measurably different biological foundation than 90 minutes of defaulting to cultural habit. The interventions are not expensive, they are not time-consuming, and they do not require pharmaceutical assistance. They require understanding the biology well enough to make different choices. The 5 mistakes I described, immediate phone use, immediate caffeine, high carbohydrate immediate meals, alarm snoozing, and skipping morning movement, are each individually impactful. Compounded together, practiced daily for months and years, they represent a systematic suppression of the biological systems designed to make you energized, focused, emotionally regulated, and metabolically healthy. Reversing them one at a time, starting with whichever produces the most friction in your current routine, is the practical approach. You do not have to overhaul your entire morning at once, but you do need to understand what you are doing and why it matters.